All right. I think all my videos start with okay or all right. I gotta stop doing that. Okay, so today we are going to talk about the stuff that we're going to talk about last week, but we're going to talk about this week. EMT bending, and this is the basics. It's just to start you up. This is quite a skill to handle, and I would encourage you to self-study a little bit on that because when you do that, you're going to gain some sort of information that you can turn into knowledge. Now, would I encourage you to buy the pipe benders? Maybe not yet. If you can borrow one, that would be great. If not, if somebody's really serious about that, then you can by all means get a 1/2-inch pipe bender. Don't get a 3/4 inch, but then again, if you end up doing this job, you will own a 1/2-inch pipe bender and 3/4 inch pipe bender, at least those two. And now, some people like the ideal one, which are the blue handle ones here, right, this one. And some people like the Klein tools pipe bender. It's a preference. The way they work is pretty much the same with slight differences, all right? And it's just a matter of getting used to it. Again, some people prefer one over the other. One thing I'm going to show you that this, the one on the right here, the Ideal by Ideal, it has an aluminum shoe here. Right? Now the one on the left, it has the ductile iron. The ductile iron, they're both available. The Klein and the Ideal, you can buy them with the ductile iron shoe or the aluminum. The aluminum is a little bit less expensive, but it's not as durable as the ductile iron. Okay? So if you might want to spend a little bit more dollars. Oh, there's some errors coming up here and some advertising on my laptop. Okay. If you really want to, you can just get yourself one or the other, but do a little bit of a research before you buy any of those. But I would definitely start with the 1/2-inch one, because anyways, this is the one that we are going to use in class and you're going to use next term. Now I'm walking you into the basics of the pipe bending. I might continue on my own, or maybe well, it depends on what subjects I get to teach in the future, but I might get some further lessons on how to do the pipe bending, just to go beyond the basics. But for now, this is what we're getting. And of course, next term, when you start your next term, you are going to use these tools a little bit more seriously. You're going to get some of the more serious bends. So by all means, get into that topic right now. Do a little bit of a self-study, and the more you are going to do that, the easier it is going to be for you later on. When you're going to get to bend a little bit more serious bends than we're going to do this term, which is going to be just an offset. Well, I use the term loosely because if you think that's easy when you're starting, think again. So here's my spiel on that. All right. Okay. So let's start with this show. Let's get this show on the road right here. What do we see here? We see the Klein pipe bender, manual pipe bender, and the Ideal pipe bender. And this is what we are going to do in our second last lab, I believe it is. We're going to do something that's called a box offset. All right, the knockouts on the box, on the electrical boxes, they are not flush with the bottom, they are raised a little bit. So we're going to accommodate that by creating a box offset. So the conduit is going to go nice and easy into the knockout or into the connector at the box, and the rest of the conduit or pipe is going to lay nicely against the surface. And we're going to do another one on the other side. So each everyone is going to do the two box offset at the opposite ends, just to throw a little bit of a curveball at everybody. So Brody says, so eventually we will need to get one anyway. Well, if you end up doing this, if you end up getting a job in this field, yes, you will have you will get your own. Now, tools, some of the specialty tools, these are not cheap. It's about over $100 per one, and you will need one for the half inch. Okay. And if you end up doing this job, you will want to have your personal one, because every single pipe bender has its own personality. And if you want to do the job safely, fast, and efficiently, you are going to want to have your own tools that you are actually resonating with. All right. But for this class, it is provided. Yes, we will provide those. These are the ones that are actually, when you walk into the lab, they're hanging on the stairwell sidewall there on one end of the class, and then you go to the other far end of the class. There are more. So yes, those will be provided for you. Okay? All right, and of course the demo on how to do it and all that stuff. Okay? All right, so let's just start with some definitions from the last time. EMT stands for electrical metallic tubing, and well, when you're working in this field, you're going to hear a lot of that EMT. It's basically a raceway. What's a raceway? A raceway is a physical pathway for electrical wiring. Raceways protect wires and cables from heat, humidity, corrosion, water intrusion, and general physical threats. Plus, in some ways, we absolutely have to install the raceways of certain type in order to comply with the code. All right, so as an electrician, you will be required to install raceways as part of your job. The EMT serves as a raceway for the cabling infrastructure, so it's a bit of a repeat of an idea here. The ability to bend conduits is a requirement for all electricians. Now, some people get more comfortable than others when doing that. Of course, there is going to be some jobs that you personally will prefer over others. However, you should be able to do all jobs when required. That's the idea of this school here, of what we're doing here. Now here there's a bit of a picture of really well done raceway system, wherever that is. I got this picture off the internet, and there's a reference down below. So once you download this, you'll be able to follow that link if you want. There is a lot on the internet there when it comes to pipe bending. Okay. Now, next slide. We're just going to go over some of the types of the electrical of the raceways or the electrical tubing. So EMT, all right. So that's the one we were going to use. Electrical metallic tubing made of galvanized steel, but also can be made from aluminum. Also called tin wall because the walls that of the whole cross section of this material, they are tin, all right? So it's called tin wall. Conduit because of its thin wall and lightweight. EMT is rigid and can be bent with a simple tool called a conduit bender, which is basically the stuff that we were looking at right here. Okay. With some of the heavier tubing, there's no way you're going to have to use some mechanical devices. Right? Okay, now installed with couplings and fittings that are secured with set screws or compression type fasteners. We'll have a couple of pictures. Next slide. The tubing itself is non-threaded, so basically there is no thread like for screwing things on, right? So basically it's just raw pipes, and you can cut them to length. The tubing itself is non-threaded like the RMC and IMC. Okay, so we're going to see what those two are in the next couple of slides. Common sizes of EMT include 1/2 inch, 3/4 inch, and 1 inch. There are also 2-inch pipes. These are the common ones. It is commonly used for exposed indoor wiring runs in residential and light commercial construction. If installed outdoors in exposed locations, it must be assembled with special watertight fittings. All right, now here's the RMC and IMC. What we're talking about with this one here. It is a rigid metal conduit. It says here on the previous slide, that this is rigid. It is rigid in the terms of that it is tough enough, okay? But then there is one that with a prefix that says rigid metal conduit, so it's more rigid even than that, all right? So now, it's a heavy-duty galvanized tubing installed with threaded fittings. See here, there's a threaded fitting right here. Oops, a threaded fitting right here. I was using the wrong mouse. And the walls are a little bit thicker than the EMT, all right? So installed with threaded fittings, typically used outdoors to provide protection from damage. Can also provide structural support for electrical cables, panels, and other equipment. So not only it can serve as a raceway for wiring, but when properly installed, other things could be fastened to it within the rules of the code. Usually you're going to see, after the whole construction job is done, you're going to see a bunch of wires being strapped, like data wires, communication wires, and whatnot, right? When allowed, all right? Sold in 10-foot lengths. Mostly you're going to see 10-foot lengths. However, 10-foot lengths, and 20-foot also are available for both lengths. Okay, and they have they are threaded on both ends. Intermediate metal conduit. Well, from this rigid, which is tougher than the EMT, we go into the intermediate metal conduit, which is basically the metal is being used is not as thick walls. It doesn't have as thick walls as the rigid conduit. Thinner, lighter weight version of a RMC, which is the rigid conduit, approved for use in all the same applications as RMC. Because of IMC is lighter and easier to work with, RMC is becoming more and more popular with the new construction. Oh, where's the button? Right here. Okay, now we move on to the ENT, right? Electrical non-metallic tubing, flexible, corrugated plastic tubing, corrugated, I guess. Moisture resistant, flame retardant. Okay, so it's not like it's not going to burn. It is going to burn, but it's not going to burn as quick as the regular PVC or some other plastics. Regular PVC. Easy to bend and installs with a snap lock or glued plastic fittings. Cannot be installed in exposed locations. All right, so it's just for the inside. Commonly used in inside walls, can be installed inside a concrete block structure, so that's important, and can be covered with concrete. Due to the blue color of the common brand of this conduit, the ENT is nicknamed as Smurf tube, after the Smurfs cartoon characters, right? So and there's a picture of what this looks like. I would advise you to just go and visit some of the hardware stores, some of the major hardware stores, or even some of the local ones as well, and look at some of the electrical section. See the Raceways, see the tubing, see the EMTs, the metallic tubing, and see other PVC types of tubing, and just get familiar with all that stuff. Then there's FMC and LFMC, flexible metal conduit, and liquid tight flexible metal conduit. All right, there's examples of both in the picture here. Also called Greenfield, after the name of the inventor. Spiral construction that makes it flexible, so it can snake through walls and other structures. Sometimes you want to have that flexibility still. Standard FMC is used in dry indoor locations, so this one here on the top, used often in short runs between a wall, box, and a motor. So mostly you're going to see this a lot in the industrial setting, or some of the short runs. Yes, you can still use them in a construction site. All right, or fixed appliances such as garbage disposer. Right? Now, see, there's the same thing that's flexible metallic tubing, but with the L prefix before that. So it's an FMC with a plastic coating. So here it is, used in sealed fittings to make it watertight. Right? Commonly used with outdoor equipment such as air conditioner units. Next, we're going to look at the rigid PVC conduit. Polyvinyl chloride, PVC. Is this posted on FO? Yes, it is. Polyvinyl chloride, PVC. No. I can only find last week's. Let me see here quickly. Just want to make sure that this is posted. I'm looking at that. You can't see what I'm doing, but here, content. Is it under student items? Yes. And it's visible. Week 8, Safety 1051-21, Lecture 6, CEMT Conduit, Bending Basics 1. It's under the students' items. And yes, I posted that in the right. You just give me a bit of a scare. All right, so we keep going here. Now, basic EMT sizes. Right? Electrical metallic tubing EMT. So we're looking at the EMT right now because we're going to be working with the EMT. So electrical metallic tubing, also commonly known as a 10 wall. So there's a repeat from previous pages. Steel raceway of circular cross section. Well, okay. Unthreaded, so there's no thread on it. Offered in 10-foot sections, but 20-foot sections are less common, but also available. Trade size, 1/2 inch through 4 inches, up to 4 inches. And obviously, if it's a 4-inch pipe, you're not going to use a manual pipe bender for that one. Right? The outside is galvanized for corrosion protection. The inside has an approved corrosion-resistant organic coating installed by the use of the set screw or compression-type couplings or connectors. Right. So here's an example of a connector. Remember, we used the 2-screw connector to connect the NMD90 cable into the device box. So the part that goes into the box is just the same with the lock nut right there, but the other side of it, it is used to accommodate the EMT piping, and there are different sizes. So for 1/2 inch, you would use 1/2 inch, and here is the set screw. So here's a set screw EMT connector, and here's a compression EMT connector. And again, the side that goes in the box is just the same for everything because it has to accommodate the knockout on the box. And to accomplish the compression of it, so when you tighten the gland ring here, you are going to compress the inside of this fitting right here to make it tight on the conduit. And those are being used when you need to have some watertight fittings. What did I put here? Okay, so over here I put a link for YouTube. I found a YouTube little clip that actually shows how to use the compression connectors, just so you're familiar with that. So when you download the PDF version, just click on it. Okay, is somebody calling me out here? Jasper, you have a question or just okay, no problem. All right, cool. All right, basic EMT sizes. My Wi-Fi keeps going in and out. Yeah, this all the lessons are on YouTube, so you'll be able to just you know how to get to the our YouTube playlist. It's in the announcements. Okay, so this is going to be added roughly about 15-20 minutes after this class is done. Okay. EMT sizes, we're not going to go over all of them here. However, just so you can see some of the common sizes. So here's imperial in inches or metric. We're going to concentrate ourselves on the imperial sizes in inches here. So here's a trade size. This is the inside diameter of the conduit. Okay, so here's a 1/2 inch, 3/4 inch, 1, 1 1/4, 1 1/2, 2, 2 1/2, 3, 3 1/2, and 4. Most of the time you're going to use 1/2 inch or 3/4, 1, and maybe 2. 4, well, these are the bigger jobs there, right? But still, of course, they are available, and by all means, you might actually get to use those depending on the jobs that you're doing. Now, the metric in millimeters or millimeters, that stands for millimeters. So that's the equivalent of those imperial sizes here. Now, nominal weight per 100 feet, all right, or 30.5 meters. 1/2 inch, 100 feet of 1/2 inch would weigh about 30 pounds. Now, as we go along and the size of the conduit is increasing, of course, the weight of that is going to increase. Here's the weight in kilograms as well. Now, outside diameter, it is going to be a little bit bigger than 1/2 inch for that because you have to accommodate the thickness of the wall that is being used, or the thickness of the metal that's being used to make that pipe, right? And so here's the wall thickness in inches and in millimeters. So see, the 1/2 inch conduit is, well, okay, I'm going to use 1/2 inch, so imperial and the millimeters now, right? We have the luxury of using both systems here. So 1/2 inch conduit is going to be made out of 1 millimeter thick metal, and so on. So the thickness is, of course, then there's more metal, more steel or aluminum is going to be used. All right, so you can just see that for your information. All right, now let's keep going. Now we're going to, there's a whole science behind the whole pipe bending. This is an introduction to it, right? And you're going to go a little bit further than the first step of the introduction. You're going to actually use that to make a couple of box offset bends. Now, types of basic bends. When you have a pipe that is going to be bent 90 degrees, it's called a stab up bend. Right? So a stab, so here's a stab and here's a leg, right? Stab and a leg, all right? 90-degree bend is called a stab up bend or a stab, shortly speaking, okay? But stab up is the correct full name of that type of a band. Right? And right beside that, we have something that's called a back-to-back band. Notice the back-to-back band is 2 stab abs, all right? 2 90-degree bands, back-to-back. You might want to use that information for later on when you do all the calculations, when doing different types of bands. It is okay to treat this back-to-back band as 2 back-to-back stab abs. Okay? Right. Continuing with the basic bands. Now we have an offset band when we have a pipe continuing on one plane and it has to change the plane. So maybe there's one wall and there's something, the wall changes its planes, maybe there's another wall or some sort of obstruction that you have to overcome or change the height or the level of the pipe running through or on. Then you would use something that's called offset. You run it here and then you have to go a little bit higher and you just keep running the pipe. Right? And then right beside that, here is a simple band that's called a box offset. So it's not only it's an offset, it's a box offset to accommodate the height of the knockout of the device boxes. Very, very common thing. So in our second last lab, we're going to connect 2 boxes with 2 box offsets on each end, and it has to be done nice and clean and straight. All right, and we'll have some fun with that. Trust me. Okay. All right, now. Another band, another couple of bands here. We got the 3-point saddle and a 4-point saddle, right? Where do we get the 3 points? Point number 1, here's the first band, here's the second band, there's a third band. So that's why it's called a 3-point saddle. Usually it's done to accommodate obstructions. Okay? And then if there's some wider obstructions here, we're going to use something that's called a 4-point saddle. 1, 2, 3, 4. All right, 4 points. And it's called the saddle. Notice the 4-point saddle would be 2 offset bands back to back. Right. All right, now the last one that I'm going to show you, it was hard for me to find some sort of drawing of that. It is called a kick. Right. Sometimes what is going to happen is that when you need to make a box offset, this is an exaggerated version of that, probably just for demonstration purposes. You might see some of those kicks as going even further than that, right? But quite often, when you have a pipe that you're supposed to do a 90-degree band and then do a box offset, and it's going to be so close to the band, you are going to have a difficult time to make a box offset with such a short section of this pipe here. So in this case, you're just going to go here and just raise the whole thing a little bit, and that's called a kick. Okay. All right, so conduit bender, or also known as a pipe bender. We're going to have 2 pictures of the same thing, one magnified with just a shoe. Would it be a tripping hazard? Okay, this here. No, this, yeah, well, if it was laying like that on the ground, yes, that would be a tripping hazard. But this is just for demonstration purposes. Usually you see those on the walls, okay? Things like that. Mounted on the walls. All right, conduit bender. Parts of that. Here's a foot, here's a handle, here's a shoe, here's a footrest that you're going to do the bends on the floor as opposed to the ones that are being done in the air. So, excuse me, here's a little bit of a homework for you. Find out which bends you're going to use in the air and which bends are you going to use on the ground for the most part. Now, of course, then you're going to have to find out what does it mean to bend in the air or bend on the ground or on the floor. And certain types of bends are recommended to be done in the air, and certain types of bends are recommended to be done on the floor or on the ground. Same thing, magnified. You're going to see some markings. So on that, so it's a conduit bender anatomy continued here. Marks. These are the marks here. These are not the marks that you do get on the test. These are the angle marks right here. All right. And there's a hook. You're going to put a pipe or conduit right into that circular type of a hook, and you're going to bend it that way. And depends on how many degrees of a bend you're going to use. You're going to make that pipe parallel with whatever mark and whatever the degrees. Right here. And now we have some other marks. We have an arrow right here, used to line up offset and outer marks for the saddle bend. So offset bends and saddle bends, you're going to use that arrow on that. You're going to do some markings on the pipe, and you're going to align those markings with the arrow, and then you're going to bend that. So mostly it's going to be for the offset and for the saddle bends. And there's a whole science of how to do it. Rim or notch. Rim notch or a, sorry, rim or notch. Rim notch is going to be a notch or a teardrop right here. That locates the center of a 3-point saddle bend. So it's not to find the center of the 3-point saddle bend. You're making a mark with a pencil or a Sharpie marker on the pipe, and you align that mark, and then you do the bend. Okay. And then there's a star, indicates the back of the 90-degree bend. So it's for stabs and for back-to-back bends. You're going to find the center of that. So you're going to mark the center of that on the pipe, align that with the star, and do the bending. And of course, the other angle markings on how much you're going to have to bend the pipe, and how you accomplishing the angle. You're making the pipe parallel with the line of whatever the degree is. They're actually the degree marks how many degrees you want to bend the pipe. Okay. And over here is the footrest. We have that here. Yeah, there's a footrest. If you're doing on the ground as opposed to in the air, you're going to flip it upside down, and you're going to press that with your foot in order to help yourself to give you some more power when you're bending the pipe. I know it might be a little bit intimidating, but just relax. Okay, you're just getting that, and you're going to do little by little, one by one. And when you go back and rewatch this video, it's going to be making more and more sense. All right, this is just an introductory lesson. Do not be intimidated by that. Seriously, don't get intimidated. It's all good. So here also there is something that's called a Hickey Bender. Now you can see that this whole body of that is a bit shorter, and mostly it's used for small bends with shorter segments, where this regular pipe bender would be just too big to accomplish some of those shorter segments. All right, so here's the last slide. How serious is pipe bending? Pipe bending is quite serious. In fact, I'm going to make a bold statement. If you're really comfortable with that, and if you master this craft of pipe bending, you're going to be valued a lot within the trade. Okay? That's all I'm going to say about that. And that's all I have to say about that. Now, going to the Olympics. You know what? I don't know. You see, it's interesting. Curling is an Olympic sport, but pipe bending is not. I don't know. It could be interesting if maybe somebody's going to get some idea and make an application for that, because it's actually pretty good. It's just you use your muscles and you work up a sweat when doing that, and it's healthy for you as well. Right? All right, so I just gave you a little bit of an example. You can click on this and watch a competition in the pipe bending, and people win money for it. Right, so these are not people who are just practicing for the pipe bending. These are people who work in the field, and they actually enter the competition for the pipe bending. So you can use the. I don't want to play it on here. Street disrespect for no. Let me tell you how much I respect curling. On scale of 1 to 10, 10. So there you go. It is a proof that I do have utmost respect for curling. Okay. Yeah, I just proved it. Okay, see, 10 from a scale from 1 to 10, 10. All right. So I can't argue with that. All right. All right. So you can watch that and get yourself worked up and fired up when it comes to doing that. So all right. So this is basically the end of the lesson today. Now, if there's someone who wants to did somebody send me an email or not? Let me just quickly take a look at this. No emails. All right, I'm gonna wait a couple minutes if somebody wants to stay to go over their personal tests and quizzes. I can do that. If not, I'm just going to shut down the session. But right now, I'm going to stop the recording, and that is going to be it for the. That's going to be it for this lesson. Okay, thank you very much. Oh no. No. Stop recording.